Hey y'all, I want to show you how to find derivatives using the product rule. So in order for you to use the product rule, you're going to have to find an expression or be given an expression that is a product. And all that means is you're going to find an expression, a problem that looks like it's being multiplied, and you're going to go ahead and follow the product rule I'm about to give you. So let me go ahead and outline it for you. This is the formula. It's going to be f of x times g of x equals, so here's the equation part, right? It looks like two little pieces being multiplied, equals f prime of x. This little stick thing I drew, that's prime, times g of x plus f of x times g prime of x, right? That's the formula. Basically, it's asking you to find the derivative of that first term, leave the second one exactly as it is, make a plus sign, then leave the first one exactly as it is, and then find the derivative of the second one. And that's pretty much all you do. Product rule is one of the easier ones when you're finding derivatives, all the rules of finding derivatives. But the thing is, like, sometimes you're going to have to do additional things. Sometimes this whole entire thing can be the final answer, but sometimes it's not. Sometimes you might have to factor. You might have to distribute. You might have to add everything together. So sometimes there's an additional step or two or four when you are trying to find the derivative of products. Another formula that's a little bit easier to look at is this right here. It's A times B, right? So it's like two little guys being multiplied together. And it's going to be A prime B plus AB prime. These are both exactly the same, but basically what it's telling you to do is you're going to repeat your equation twice. The first time you're going to find the derivative of the first term, and then you're going to repeat it again and just find the derivative of the second term. These are both the same thing. I do have some examples. Let's see. So I have this example here, and I did write the product rule up at the top if that helps you out. So let's go ahead and walk through it. So every time you see that little tiny stick thing called prime, that means you're going to find the derivative. So it looks like it's asking me to find the derivative of the first one. So this is A and this is B. It's also f of x, and then the second one is g of x, whichever formula you're following. So let's go ahead and do it. So it's asking me to find the derivative of the first one. The formula I'm using is nx n minus 1. And that's when I take the nth degree given, I throw it up in the front, and then I subtract it by 1. That's the derivative formula I'm using with these. So that makes 2x, 2 minus 1. Oh, I forgot the minus sign. 2 minus 1, right, times 3x. We leave that b by itself exactly as it is. I do a plus sign, and I'm going to leave a as it is, and I'm going to find the derivative of b. That's 3 times 1. The derivative of 3x is just 3. Let me go ahead and clean it up. I have 2x, 1, for my nth degree. We can leave that empty if you want, times 3x plus 3x squared. All I did is take this 3 and I move it up to the front. My 3 is a constant, and I turned it into a coefficient. A constant is a number naked by itself. There's no alphabets touching it, right? And if you throw it in front of a variable, in front of an alphabet, it becomes a coefficient, right? So this is a coefficient, this is a coefficient, this is a coefficient, right? So all I did is just move it to the front. You don't necessarily have to, but it's just a cleaner version, right? So let's see. It looks like I could still do more things. Let's take these two terms and then put them together. So 2 times 3 is 6x squared plus 3x squared. It looks like I have the same base, so let's go ahead and add them. 6 plus 3 is 9x squared. Great, this is my answer. Did you notice we used the formula we were talking about, but then there was a couple of extra little steps I had to do? So that's usually what happens. You kind of have to keep working on it a little bit further. Let's do another one. This is a really good one. I like this one. It's the same idea, but it's very detailed. So this whole thing, this entire thing, and this entire thing is considered one term. So this is A, this is B, the whole thing. Or f of x, g of x, right? So let's see. Let's go ahead and find the derivative of the first term. So that's going to be 4. I guess I should write the formula down I'm using. I'm using n x n minus 1, right? That's the formula I'm using. So I'm bringing my 2 down. T is going to be 2 minus 1 minus 1, right? Because that t becomes a 1. That's A. B stays exactly as it is, right? As per the rules, that's cube 8t squared plus 12. I'm going to do a plus sign. Now this time I'm going to leave A precisely as it is. In the when I say precisely as it is, we're referring to the original equation that it gave us in the white font. So I'm literally just writing down exactly what's in the right white font, word for word. Now I'm going to find the derivative of gx. That's going to be 3t 3 minus 1 minus 8 times 2 t 2 minus 1 plus, so let's see, 12 is a constant, right? So we know it's a constant because it's by itself. There's no alphabets touching it. When it's asking you to find the derivative of a constant, it's always going to be 0, right? So 12 is going to be 0. I want to clean this up a little bit because there's a bunch of little math problems in here we can solve. So let's go ahead and do that. So over here I have 8t, right? 4 times 2 is 8. 2 minus 1 is 1, right? I'm going to do that. That's A. And then B was exactly as it is, so there's not much concentration there. It's plus sign. And then that A is exactly as it is. Okay, then I have 3t squared minus 16, right? Because negative 8 times positive 2 is negative 16. T and 2 minus 1 is 1, so we can keep that blank. The nth degree is going to be 1. I'm not going to include that 0. I just don't think it's relevant. I want there to be less clutter as we progress through these problems. It's just easier to leave it out. You could include it. I suggest leaving it out, personally. Okay, great. So I have the product rule down. I've completed that. So here's the thing. There's a lot going on in there, right? This is not the final answer. I have to distribute now, right? Because anytime you see a bunch of parentheses, you're going to distribute. There's a very high likelihood that that's the next step. So here's the thing. It's going to be a lot of distributing. I'm going to take this 8t. I'm going to distribute it here, here, here. I'm going to take this negative 1, distribute it here, here, here. Same thing with 4t to the second. Distribute it here and here. The negative t is going to go here and here. I'm going to have a lot of little terms, right? And it all leads up to something. It's not just going to keep expanding. It's going to tighten up a little bit. So let's go ahead and just start doing that. So I have everything kind of cleaned up already. So now we're going to go ahead and multiply 8t times t to the third power, right? Cube. 8t4. I'm essentially, what I'm doing is I'm doing a n times m equals, I should probably do more room. Okay, let me rewrite that. I feel like there's not enough room. The formula I'm using is, I'm going to do it up here. Oh, okay. A n times m equals a n plus m, right? That's the formula I'm using. Why am I using that formula? It's because this right here, do you see this little dot right here? Well, it's supposed to be a dot. That's how I know to use this one, this particular formula. There's another one that looks like this, a n m. It looks almost it's like same, right? Except it's asking you to multiply together. We're not using this one. We're using this one. That's why we have a 4 for our nth degree, right? So then 8t times negative 8t to the second power is going to be 64 t to the third. And then we have 8t times 12, that constant, is going to be 96t. Okay, and then we're done with that, right? So now we're moving on to the second one, which is in negative 1. Negative 1 times t to the third power is going to be negative t to the third. Then I have positive 8 t to the second, and then I have negative 12, right? That's the entire thing. We can get rid of that, right? That is my first guy. I'm going to do a plus sign, and I'm going to do the other part. I have positive 4t to the second times 3t to the second. Great, so that's going to be 12t to the fourth power. And it's going to be negative 64t cubed, or to the third power, negative 3t to the third power plus 16. It's going to be positive 16t to the second. It's positive because negative t times, which is going to be like basically negative 1, times negative 16 gives me positive 16t squared, because I have 2 of them. Right? The formula is A n times m. We're going to add them together. Great. So that's part 1, that's part 2. We did this guy, we did this guy, we can get rid of him. We're almost done. Now I have to find the like terms, right? I have to find the like terms all inside this, and then again all inside this. They're considered 2 separate pieces right now. So let's see. Do I see anything similar? Yeah, I do. I see these 3's that are similar. I'm looking at the nth degrees. I only have 1 4. I have 2 3's. I have a 2, just one of them. And then I have just a t by itself, or like a degree that's like nth degree 1. And then I got that constant. And then the same thing with the second one. I have repeating 3's. Let's go ahead and put those together. So I'm just going to go ahead and rewrite it. I have 8 t to the fourth power. We got rid of that. And now these negative 64 minus 1 is going to give me negative 65 t to the third power. I'm getting rid of those. And then let's see, 4. Okay, and then I have 8 t to the second power plus 96t minus 12. Great. Plus 12t to the fourth power, and then negative 64 minus 3 is negative 67t to the third power, this is looking bad, to the third power plus 16t squared. Get rid of these guys, this guy's gone. Sweet, okay, cool. Now I got these left. Perfect. There's no more repeating stuff. There's nothing to distribute anymore. All that's left is just any like terms at all across the entire line I just made is going to get added together. So let's see. That is 8t to the fourth power plus 12t to the fourth power gives me 20t to the fourth power. Bam, bam, those are gone. And then I have negative 65t to the third power plus negative 67t to the third power gives me 132t. Okay. Let's see. Oh, I got 2 square stuff. So I got 8t squared plus 16t squared is 24t squared. Those are gone. And then I got, do I have anything? Oh yeah, I do. I have a 96t. I almost missed that one. Got 96t, and then I have negative 12. Perfect. Now this could be the final answer. Actually, I'm going to go ahead and make it the final answer. You could keep extracting stuff. You can't pull out a t because of that constant, but you can pull out other numbers, right? So I'm just going to leave it. So you can keep simplifying. Let's see. This is a good one. I like this one a lot. Okay. We're going to follow the same idea where I'm finding the derivative of the first, leaving the second as is, plus sign, leaving the first as it is, finding the derivative of the second one. So let's see. What is the derivative of, I guess I should do that formula again. I feel like it helps. Nx n minus 1. And we'll need one for ln in a minute. Okay, so we're going to do 3x, 3 minus 1, ln, x stays as it is, plus, I'm going to keep x to the third power as it is, and I'm going to transfer ln x into my derivative that I need to have. So what is the derivative of ln x? What could it possibly be? So this ln x is 1 over x. That's its derivative. Okay, so we're going to do 1 over x. So let's clean it up. I'm going to have 3x to the second ln x plus x to the third over 1x. So we can actually reduce that further. Let's get rid of this. That gives me 1, and that gives me x squared, right? So it becomes 3x squared ln x plus 1 over x squared. This could be the answer. Let me just try to box this. We can further reduce it. Let's see. 2. Oh, this is... Okay, it's supposed to be 3x squared ln x plus x squared, because right here I messed up. Because we had 3x, 1 over x, right? Which becomes x, 3x. This becomes 1. This becomes a 2. It's in the numerator. So that means it's just x squared, right? So that could be this could be the answer right here. But we can also factor out the x squared, and it becomes 3 ln x plus 1, because I need that placeholder. So both of these are correct. Both of them. So let's try another one. So this is a really good one too, because if you recall, ln x, its derivative was 1 over x. But we also have 1 over x. I also have 1 over x. So what is the derivative? Is it ln x? Could it be? It's actually not. It is not ln x. The derivative is not ln x. And we'll go through this one really quickly. So step 1 is I want to rewrite this, just because it's going to be easier if this is not a fraction. If there's an opportunity to get rid of a fraction, try to do that. So I'm just rewriting it right here. So I'm going to do x negative 1 ln x, right? All I did is I moved up the x to the top, and I gave it a negative 1. If there is nothing provided, it's understood it's a negative 1. If there was a 2, I would do negative 2. If there was a 7 over there, then I would do negative 7. And because it's in the bottom, the denominator, it has to be a negative, right? So that's an indicator that this is a fraction that we converted into something different. So now that we have this set up, it doesn't look like it would be ln x anymore, right? It doesn't look like this would be like the derivative is ln x. Now it looks like I can just go ahead and follow the formula I've been using, which was n x n minus 1, which would be negative 1 x negative 1 minus 1 ln x, right? Plus, I keep that exactly as it is. And then I find the derivative of ln x, which is 1 over x. So then that gives me negative x negative 2 ln x plus x negative 1 x negative 1. This is the same thing. I just rewrote it, which gives me negative 2 ln x plus x negative 2. Do you see a pattern? All I did is put these together. X negative 1 is x negative 2. That's all I did. What does that look like if I were to make it fractions again? It would be negative 1 over x squared ln x plus positive x squared, right? This could be the answer. But we can factor stuff out. You know, I could do half, oh wait, not half, 1 over x squared. I can factor that out. So then I'm left with negative ln x plus 1. That's my placeholder. So this can also be the answer right here. If I wanted to make it look a little bit more clean, I can just flip everything inside that parentheses. So there's not a negative sticking out. So I would do 1 minus ln x. All three of these are correct, right? So I wanted to show you both versions because you're seeing that, let me erase this right here. You're seeing that the derivative of ln x is 1 over x, but the derivative of 1 over x is actually negative 1 over x squared. So that's important. That's like something I would personally put in my notes, right? So, because it seems like it's no big deal, but you know, if you have like a lot of pressure during like exams and quizzes, you know, you might notate the wrong information, even though you studied, you know, diligently and ethically, and you did everything you could. And sometimes stuff like this can cause you to lose points. Let's do one more. I want to do like a trig one. Okay, so this is supposed to be, this is my nth degree. It's kind of tough looking where it doesn't look like that. If I were to rewrite it, it looks like this: 3 over 2 times tan x, right? And it's the same idea. We're just following the exact same method, except I just have a trig concept thrown in there. So let's go ahead and do this. I have 3 over 2. We don't have to flip the fraction. We just throw it down. That's it, exactly as it looks, right? I have the x right here. I have 3 over 2 minus 1 times tan. We leave b or g exactly as it is. I do a plus sign, and then I leave the first one exactly as it is. And then the second one is a derivative. The derivative of tan x is secant squared x. I have a video that shows you how to memorize some of these. There's like visual references, stuff like mnemonics, if it helps. So it's going to be secant square x. So let me notate that right here. Cool, perfect. So now I'm just going to do a little bit of math. So I have 6 times 3 is 18 over 2x. Negative 3, let's do this off on the side. I have that fraction. See, the thing with algebra and calculus is like you got to know your fractions. Like sometimes you can get away with it, but man, it gets tough like once you're just kind of there. So I'm going to find the same bottom part, right? The denominator, it's 2. 3 minus, it's asking me to minus. That's why I know to put a subtraction there, right? So 3 minus 2 is 1. It's positive half. So I know that my nth degree now has become positive half. I still have tan there, plus 6x 3 over 2 secant square x. So I can further simplify. 18 divided by 2 is 9x half. Tan plus 6x 3 square secant square x. I think I said square. I meant to say 6x 3 over 2 secant square x. I don't think I remember what I said. Okay, perfect. This could be the answer. I mean, I would pick this as my answer. It looks good to me. But I mean, you could extract, you could pull out a 3 and then it becomes 3 tan, oh, I forgot this x. I forgot this x here too. Oh no. Okay, 3 tan x plus 2x, yeah, 2x secant square x. This can also be the answer. Both of these are chill to go. Yeah, I think that's all my problems. I don't think I have any more problems. So this is how you find derivatives using product rule. I hope this video helped. And I do have a sticker shop if you guys want to check it out. I have vinyl and matte stickers, which is super fun. Okay, thanks guys. Bye.